Let's start with concrete. As I mentioned, it's two parts. The first part is the concrete body poured, cast in formworks that takes the shape of the structural elements with reinforcing in it. So these bars, the spacing with them is very sensitive, precisely calculated. The diameter of the vertical bars, the diameter of horizontal bars, this is all indicated on the structural drawings, and these serve a structural function. So during construction, if these spacings are not correct, if the diameters are not what they're supposed to be, this could directly affect the integrity of the structure. So obviously, site checks and site visits are going to be critical just before pouring the concrete. I want to explore here some of the structural elements. I will go deeper into them, but what the building is made out of. There are mainly two groups of elements. Vertical elements, typically called columns, so everything vertical. These are called columns. Horizontal elements, they could be from the same material, even from the same cross section. But just because they're horizontal, they experience different stresses, more flexure, bigger deformations. And those are called beams. So those are the beams. And just like that, you can start building beams and columns, multiple floors, and you have like a skeleton, but voids in the middle. You need like a floor for the occupants to stand on it, and this is where the slabs. So you can make slabs out of concrete. This is the plate at each level. There are two more elements that I want to point to. If the column is too wide, it becomes a wall. So this is what a wall is. They are very important in resisting lateral loads. So I will talk about loads, and we will get to this later. The last piece is the foundation. There is usually two types of foundation. Shallow foundations, very close to the surface of the ground, and deep foundations, typically needed with heavy loads, or if the top layers of the soil is not strong enough to dissipate the weight of the structure safely into the ground. There is another type of concrete structures I want to mention, which is precast. Precast concrete, the structure is built in pieces in a factory or like a construction plant, and then transported on site with cranes, and then the pieces are put together. So this wall needs a crane, lift it, put it in place. This is a beam. These sections are very effective in long spans, so it can be used in bridges. And then construction is going to be relatively quick because you don't need for casting of the concrete, wait for concrete to cure, and then do these steps. These steps can be done off-site and then cast, hence the name precast, transported, and then build the structure. The most common type, I see it a lot in multi-story buildings, hollow core slabs. Hollow core slabs, they are precast and they are also pre-stressed. The reinforcement in the concrete, I mentioned reinforced concrete always needs to have reinforcement. The reinforcement in precast hollow core slabs is pre-stressed. It has additional stresses that helps the structure counteract the gravity loads. I will mention this in this slide. So think about it this way. In red, these forces are actual cables, strands, very high strength steel, and they are installed in conduits. You can see it over there inside the concrete. And it depends on the sequence. If it's pre-stressed, the stressing happening before pouring. If it's post-tension, the tension happens after pouring the concrete, but the concepts are fairly similar. After the concrete is cast and there is a hard beam like that, these strands are now stressed, very high forces, that this parabola, this curve, because of the stresses in the concrete, wants to straighten up the beam. So it's going to introduce an upward force just before any loads touches the beam. So let's say this is the undeformed beam with no loads on it. If you apply a load on it, this becomes the deformed shape. So for a post-tension or pre-stressed beam with no loads whatsoever, just because of these upward forces from post-tension, there is an upward camber. When the gravity load is applied, self-weight, live load, the deflection goes down to like a minimal displacement compared to what it would have been just on the gravity load. So they can save on the self-weight. These systems are good to resist loads over larger spans without the thickness of the concrete becoming too big. So they have some advantage to it, despite the slight complexity of adding the profiles and stressing and monitoring that the stress is being done properly. But overall, it comes with benefits depending on the individual case.